The kind of work that we do on a day-to-day basis, we're interested in looking particularly at the evolution of the skeleton. And how we do that is a lot of the work we do involves capturing 3D digital data sets. So we would do that by perhaps CT scanning fossils. So that means subjecting them to X-rays, which allows us to look at the internal and the external features. Sometimes we also use other methods such as surface scanning, where we pass a laser or a light over a fossil structure, and that creates a 3D model. And with that 3D model, what we can then do is use methods to look at how the skeleton might have functioned. And that gives us a clue to how these animals may have behaved in their environments. And it also gives us a clue to why the skeleton is shaped as it is and how it may have evolved and why it's evolved in such a way it has. So I did an undergraduate degree in biology. It was my favourite subject at school, and I wanted to carry on studying it at university. And while I was studying biology, I became really interested in the biology of extinct animals, and how we can understand how these animals lived and breathed, and the limits to our knowledge, basically, and the limits to what we could understand. And then had a year where I worked in a medical lab, and I realised that lab work wasn't necessarily for me. And so then I returned to study for a PhD, particularly focusing on looking at the evolution of function of dinosaur skulls, using new methods to understand how they may have functioned during feeding. I think as scientists, one of the key things, and just as in general, what motivates all of us is actually addressing questions in new ways and finding out things that no one has ever found out before, or looking at established questions from a different angle. So a lot of the work that we're able to do with the computational methods is taking ideas that people have had in the past, but actually being able to derive hypotheses to say, well, did it actually function like this? Or did that structure work like that? And then use some of the methods in the lab to test that and either say, yep, that's right, or no, that's wrong, we need to move on and think of a new way of understanding. I think please don't be hesitant about going into a geoscience career. I mean, geoscience in its broadest sense, we really need so many more people in that area to solve and deal with many of the issues we're facing globally. Geoscience is such a broad area that there's a space in there for many people, working right through from things like policy and law, right through to chemistry, biology, physics. It really is quite a very broad subject.